Okay, so let's look at some exponential equations. So e to the 2x is equal to 3 to the x add 1. Well, remember we have this formula, a to the x equals e to the x ln a, so we can use a formula. So one thing we can do is we could change this into e using that. So e to the 2x equals e to the power, which was x plus 1, keeping that in brackets, times ln the base, so ln 3. Yeah, at this point I can do ln of both sides. And what will happen is that ln and e will cancel out, so I'll just get 2x equals x plus 1 ln 3. Then I'll solve this in a second. I just want to show you another way of doing it. So another way is whenever you have x's at the powers, you could think, well, ln's or logs bring powers down. So I could do ln of both sides straight away. And on this side, ln and e cancel out. Well, actually, let's bring the powers to the front first. So 2x ln e equals x add 1 ln 3, because powers go to the front. ln e is just 1. And then look, I've got the same equation on both sides. So to this point here, I can solve it. So I can just do 2x equals x ln 3 plus 1 times ln 3, so ln 3. Get x's all on one side, so 2x minus x ln 3 is ln 3. Factorize out the x, so 2 minus ln 3 equals ln 3, then divide by it. So ln 3 over 2 minus ln 3. Okay, let's try and see what impact it will have if I stick a number at the front of this equation. So I'll have 5e to the 2x. So if I do that method from before, I can change this side into e x add 1 ln 3 as before. However, the e's don't cancel out now because 5 is not part of an e. So I could change this as well. So 5 e ln 5, because that's just 5 to the power 1, isn't it? Times e to the 2x, and that side stays the same. Here I'm timesing, so I can add the powers. So e ln 5 add 2x equals e to the x add 1 ln 3. Now I can do ln on both sides, and the ln and the e will cancel out. So I'll just get ln 5 add 2x is x add 1 ln 3. Whereas the other method this time might be a bit quicker. So if I do ln on both sides straight away, so the power can't go to the front just yet because there's a secret times there, isn't there? So I need to split that up into ln 5 plus ln e to 2x, and this side can stay the same. Now I can bring the power down. Look, ln 5 plus 2x ln e equals x add 1 ln 3. ln e is just 1. And now I've got the same equation on both sides again, look. So now I can just solve that. So ln 5 at 2x equals, expand the bracket, x ln 3 add ln 3. X is on one side, and non-x is on the other side, so ln 3 minus ln 5. Take out the x, and then divide by it. Okay, now this one is tricky because there's lots of different numbers. So again, one method is change everything to e's. So this one here would be e ln 7 times e 3x ln 2. This side will be e ln 11 times e x add 1 ln 5. Then I can add the powers, so e ln 7 add 3x ln 2 is e ln 11 add x add 1 ln 5. I can now do ln on both sides, which makes the e's cancel out. So let's get ln 7 add 3x ln 2 is ln 11 add x add 1 ln 5. And then hopefully I'm going to get the same equation if I do in the other method. So if I do ln on both sides straight away, and remember there's secret times that's here. The times can be split up into an add. So I get ln 7 add ln 2 3x equals ln 11 add ln 5x add 1. Powers can now go to the front. So ln 7 add 3x ln 2 equals ln 11 plus x add 1 ln 5. So I've got to the same point here, look, the same equation, just this way was a bit faster this time. Yeah, then I can solve it. So I expand the brackets. So x ln 5 plus ln 5. X is on one side, so 3x ln 2 take away x ln 5. Non-x is on the other side, so ln 11 and ln 5 take away ln 7. Factorize out x, so 3 ln 2 take away ln 5 equals ln 11 and ln 5 take away ln 7. Then divide by the bracket, so ln 11 plus ln 5 take away ln 7 over 3 ln 2 take away ln 5. Okay, and that's it for these kind of tricks. Okay, an equation like this, you might be tempted to do this. I'll do it in red, so red means wrong. You might be tempted to say, right, well, that's 3 to the power 2x, 3 to the power x. So the opposite of 3 to the power is log base 3. So I can get rid of the 3's by doing log 3 on that side. And that gives me 3x. So then I can just divide by 3. Yeah, that's wrong. And where we went wrong is this first step here. Yeah, we can't do logs of terms separately. We can do logs of sides. So I could do, so this is right, it's just not going to be helpful. I could do log 3 of this equals log 3 of this side. That's not helpful because there's no rules when there's a plus inside the log. So instead we need to be a bit clever. So logs are going to be involved, just not straight away. So there's like a connection here, look, 3 to the x, 3 to the 2x. Well, if I say y is 3 to the x, then 3 to the 2x, well, it's just that bit squared. So it's y squared. So I've got y squared plus y equals 6. So y squared plus y minus 6 equals 0. So I can solve that. Get y is minus 3. Y is 2. Now, don't stop there. Sub back in what y was. So y is 3 to the x. So 3 to the x is minus 3. Well, that can never happen. Yeah, 3 to the x, or a positive number to the power x is always positive. Or 3 to the x is 2. So I can get x is log 3 of 2. And that would be exactly the same method if at the top here we had e's. So if we had e to the power 2x plus e to the power x equals 6, the only thing that will change, look, is y and y squared will change. So that would be e to the x and e to the 2x. And then only the bit that will change is this last bit here. So y would still give me the same answers. I'll just get e to the x is -3, which doesn't work. E to the x would be 2. So therefore x would be inverse of e is ln, so ln2. And in fact, this trick will work whatever that number was. So if it was 7, it'll be log 7.2. If it was 10, it'll be log 10.2, etc.